All right, let's talk about something that pretty much every Java developer has had to wrestle with, the database. Today, we're diving into Hibernate, a framework that totally changes the game for how your apps talk to their data. It's all about saving you from a world of headaches.
You know the drill, right? You spend hours and hours writing the same select, insert, update statements. You're manually handling connections, trying to parse through complex results. It's just a ton of boilerplate code that slows you down and is super easy to mess up. But what if there was a much, much better way?
So, here's our game plan. First, we're going to look at the old way of doing things with JDBC and pinpoint exactly why it can be so painful. Then, we'll bring in Hibernate as the hero of our story, peek under the hood to see how it works its magic, check out some actual code, and finally, explore some of its most powerful features.
Okay, so before Hibernate became the standard, we had JDBC, the Java Database Connectivity API. And look, it's fundamental, it gets the job done, but using it feels a lot like manual labor.
And these are the classic headaches I'm talking about. You're handcrafting SQL for every single operation. Then you get this result set back from the database, and you have to manually loop through it, pulling out data column by column. You're always playing translator between Java types like a string and database types like varchar. And maybe the worst part? Your code gets loaded with queries specific to, say, MySQL, making it a total nightmare if you ever want to switch to something like Postgres.
And this is where Hibernate just swoops in and changes everything. It introduces this amazing concept called Object Relational Mapping, or ORM for short. It basically lets us stop thinking in terms of database tables and columns and lets us start thinking in the language we're already using, Java objects.
So what exactly is ORM? Well, think of it like a brilliant expert translator. On one side, you've got your beautiful Java classes, all nicely structured. On the other side, you have your relational database with its tables, rows, and columns. ORM is the bridge, the middleman, that automatically handles all the translation between these two very different worlds.
And this slide just perfectly sums up the core idea. You create a simple student class in Java, and Hibernate just gets it. It automatically understands that this class corresponds to a student's table in your database. And a single student object, well, that just becomes a single row in that table. It's really that direct and intuitive.
Now this is where it gets really good. Look at this direct comparison. Every single problem we just talked about with JDBC has a direct solution in Hibernate. Manual SQL gets replaced by automatic mapping. Instead of wrestling with result sets, you just get back ready to use Java objects. Your code is suddenly database independent, and you get awesome features like transaction management and performance caching right out of the box.
So how does all this magic actually happen? Is it complicated? Not really. Let's take a quick peek at the architecture that makes Hibernate tick. From a bird's eye view, it's actually pretty simple. Your application doesn't talk directly to the database anymore. Instead, it talks to Hibernate. Hibernate then takes your requests, like, hey, save this student object, and translates them into all the necessary SQL to send to the database. It completely hides that database layer from you.
Now, under the hood, there are a few key players working together. First, the configuration object reads your settings and kicks everything off. That builds a single, heavyweight session factory. Think of this like the main command center for your database connection. You only create it once. From that factory, you can get lightweight session objects whenever you need to talk to the database. And finally, every operation you do is wrapped in a transaction, which keeps your data safe and consistent. And this leads to a very predictable, clean workflow every time. You configure everything, create the one factory, get a session when you need to do some work, start a transaction, do your thing, save, delete, whatever, and then you commit the transaction and close the session. It's a really clean, repeatable pattern. All right, enough theory. Let's see what this actually looks like in code. I think you're going to be surprised at just how simple and elegant it is. Okay, step one. You take a plain old Java object, a POJO, and you just add a couple of annotations. The @entity annotation tells Hibernate, hey, pay attention, this class is a database table. And @id tells it which field is the primary key. And that's it. Your Java class is now officially a database entity.
Next up, you need a configuration file. This is just where you tell Hibernate what kind of database you're using, where it lives, and how to log in. This little file is the key to making your code database independent. If you want to switch from MySQL to PostgreSQL, you just change this file, not your Java code. And now for the real magic.
after you get your session, how do you save a new student object to the database? Well, it's just this one line of code, session.persistStudent. That's it. Hibernate generates the insert statement, executes it, and handles everything for you. No manual SQL in sight.
What's amazing is that all the standard database stuff, create, read, update, and delete, is handled with these simple, intuitive methods. Reading an object is just session.get. Deleting is just session.delete. And updating is almost magical. You don't even call an update method. You just change the Java object's properties inside a transaction, and Hibernate automatically detects the change and updates the database for you. How cool is that?
But Hibernate is so much more than just simple CRUD operations. It has a whole toolbox of powerful features for handling more complex, real-world scenarios.
One of my absolute favorite features is the Hibernate Query Language, or HQL. And this quote just nails its philosophy. Why should a Java developer have to think in terms of SQL tables and columns? With HQL, you get to write queries using your Java class names and property names.
Just look at this example. We're not saying select star from students. We're saying from student. We're referencing the Java class directly. And we're querying the course property of that class. It's way more intuitive, it's less prone to typos, and it's completely decoupled from the actual table and column names in your database. Hibernate also gives you this rich set of annotations to handle more complex database designs. You can define relationships, like, say, one teacher has many students, right there in your Java code using an annotation like @one-to-many. And Hibernate will take care of all the tricky database stuff, like managing foreign keys and join tables for you all automatically.
And this isn't just some academic tool, you know? Hibernate is an absolute cornerstone of the Java ecosystem. It's the default choice in Spring Boot, powering countless REST APIs. It's used everywhere, from huge e-commerce platforms to internal student management and billing systems. It's battle-tested, mature, and incredibly reliable.
So, to wrap it all up, Hibernate takes the pain and complexity out of database programming using object relational mapping. It lets you map your Java classes to database tables with simple annotations, it gives you easy-to-use methods for all your data operations, and it provides a powerful, object-oriented query language.
By automating all the tedious, error-prone parts of data persistence, Hibernate frees you up to focus on what really matters, your application's business logic. So the real question is, with all that time and mental energy you're going to save, what will you build now?